Hi, welcome to our math. Today I'm doing a series of videos on radical functions. In this video we are looking at two different radical functions. We're going to look at the input, the output, the domain, and the range. Okay, so for this first one what I want to do is I want to put it 25 in for x. So I have negative 3 times the square root of 5 times 25 plus 71 plus 11. All right, so if I start playing with these numbers, 75 plus 71, 125 plus 71 is 196, which of course is 14. So this is negative 31. If I want the output to be 20, that's like saying y equals 20. This time we take the whole radical function, negative 3 times the square root of 5x plus 71 plus 11, and we set it equal to 20. When we solve this, we really want to isolate this piece. So I have to subtract the 11 over. So negative 3 times the square root of 5x plus 71 equals 9. Divide by negative 3. And get the square root of 5x plus 71 equals negative 3. And here we have a problem because you cannot get a negative out of a square root. Square roots are, by definition, positive. So this has no real solution. As for the domain, which is why this worked, to find the domain, you take whatever's under the square root, the 5x plus 71, and say that it has to be greater than or equal to 0. Well, if I subtract the 71 over, I have 5x is greater than or equal to negative 71, and then I divide by 5, and I get that the domain is x is greater than or equal to negative 71 fifths, which is the same as negative 14.2. Now I could write this in interval notation. I could say negative 14.2 to infinity. As for the range, we look at the bookends of our original problem for the range. Because this is a negative number, we go to negative infinity, and this 11 becomes the other part of the range. So our range is going to be in interval notation, negative infinity to 11, and in inequality, it would be f of x is less than or equal to 11. Okay. For our second one, we start off the same. The cubed root of 4 times 500 minus 11. And this time I'm just going to throw this right into the calculator and get 12.58. For the second one, we get the cubed root of 4x minus 11 equals negative 5. Okay, over here when it equaled a negative, we had a problem. We couldn't go any further because you cannot bring a negative out of a square root. You can, however, bring a negative out of a cubed root. Negative 8, the cubed root of the negative 8 is negative 2 because negative 2 times negative 2 is 4, and 4 times negative 2 is negative 8. So odd radicals can handle negatives, whereas even radicals cannot. So to undo a cube root, we cube both sides of the equation. We're left with 4x minus 11 equals negative 125. I'm going to add 11 to both sides and get that 4x is equal to negative 114. Divide by 4 and get that x is equal to negative 28.5. In the original directions, it says to round to 2 decimal places, which is why I am not just reducing my fraction, but going to decimal. Okay, the really odd thing about odd radicals is because we can have that negative in there, the domain becomes negative infinity to infinity, or all real, or double bar r. There is no restriction on the input, and there's also no restriction on the output. So odd radicals are oddly easy, that the domain and range are just both all real. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.